In this video, we're going to write a simple Python script using the ramp API. So, by way of tutorial objectives, what we want to do is we want to get a series of ramp binary files from a folder, and for each of the files in that folder, read the raster, generate the spatially localized statistics for the value ranges in that raster using a 9x9 kernel, and then save the new raster to an output location. So before we start, we've got to remember that there are a number of dependencies that Python needs before you can communicate from Python to the ramp API. If I go to the Python scripting help file in the ramp graphical user interface, it describes the dependencies that you need to have. So firstly, you obviously need to have Python installed. So if you don't have that already, that's pretty easy. You go to python.org, download the latest version of Python, install it on your machine. You'll also need to get a module for Python called Pythonette, which allows Python to talk to the .NET framework. And this is required because the ramp APIs are built using the .NET framework. So Python needs to know how to talk to the .NET framework to understand the ramp API. This is pretty simple. You need to, once you've installed Python, you need to simply use the pip utility at the command line and just type pip install Pythonette. So that's very easy to do. There's more details on how to do that in the link within the ramp graphical user interface documentation. So make sure you have Python installed. That's pretty easy. Go and download it, and then use pip to install the Pythonette module that allows Python to talk to the .NET framework. So once you've got that sorted, we now need to start our Python project. So I'm going to use Visual Studio. That's my preferred integrated development environment. But you could use any Python development environment that is available to you. So that might be idle, for example, or even just a simple text editor that you then write your code and execute in Python. So I'm going to use Visual Studio. So I'm going to start Visual Studio now and create a new Python project. Okay, so create new project. And I'm going to choose to create a Python application, and I'm going to call it tutorial Py example, and we'll create that project. So Visual Studio has essentially just created a tutorial Py example.python.py file for me with absolutely nothing in it whatsoever. So this is where we can start coding. So let's just put out our initial objectives. So firstly, we wanted to read a folder and get each star.ramp file. Then we wanted to read the input star.ramp raster, and for that's what we want to do next. Then we want to generate the local range statistics using a 9x9 kernel, and then we want to save the new file to save the resultant file to an output location. So that's our general workflow. What do we need to do first in ramp? So if we're using the ramp libraries, we need to first import them. So let's do that. So firstly, I need to import the Pythonette common language runtime. So this is the Python module that will allow me to talk to the .NET framework and therefore to RAMP. So that is import CLR. Okay, I know that I'm going to read through a series of files, so I'm also going to import the glob module. The glob module will allow me to iterate through a series of files by specifying a file path and a pattern. The next thing I need to do is to reference all of the RAMP libraries that I'm going to use. So for a start, I know that I'm going to use RAMP core. So I simply go CLR, so I'm adding a reference to my RAMP core library to the Common Language Runtime. Now, where do these libraries exist? Well, we looked in a previous video about the different libraries that you would need to use, and the RAMP core one being the fundamental library if you're using RAMP. And we talked about that DLL being found in the installation directory of wherever you have installed RAMP. So we're going to add a reference to that. Okay, now the next thing we're going to do is get all of our input files. So get all of the input files. That would make sense. Oh, sorry, we've already mentioned that here. Don't need to build that step again. So to do that, I'm going to get a files list, and it's going to equal glob.glob. And we're going to get all of the input data, which is in, I think it's called batch, and it is all of the RAMP files in there. Let's just quickly have a look at that folder location. So here's that location, and you'll notice I have 4 .rmp files. So these are bathymetric data sets or terrain data sets that are in the RAMP binary format. So there's 4 of those in this folder, and those are the 4 files that I'm therefore going to process. So now I need to set up a for loop to go through each of these. So let's do that. For file in files. That's simply going to take each of the files in the file listing and return the file for that particular file listing. So now I've got a for loop. I need to indent these because this is where I'm going to do my sort of iterative processing for each of these files. So the first thing I need to do is input or read the input raster. So I'm going to use the RAMP utilities to do that. So let's go look at the RAMP documentation and the API reference. And in the RAMP namespace, I have a utils class that includes the read method. The read method takes a string, which is the path to the input file. It takes another string, which is the defined format of that file, and it returns a raster object. So that's what we're going to call this static method under utils. So let's do that now. So we're going to say, firstly, we need to import utils. So from RAMP import utils. And then we're going to say utils.read, and then we're going to give it the file, and we're going to tell it that it is a RAMP format file. Okay, so what we haven't done is actually told it that it will return a raster, so we want to call that raster input raster, and so that's done. Then we want to generate the local range of statistics using a 9x9 kernel. So if we go back to our RAMP documentation, we go to our processes, we remember in local statistics we have a method called range. Now if I scroll down and have a look at that, range is a function that I can call using the processes DLL and this particular namespace and class, so ramp processes.local statistics. So what I need to do is I need to basically add a reference to the processes DLL, and then I need to import the local statistics class and then execute the range function, which takes a raster as an input and a kernel size as an argument, and returns a new raster. So let's have a look at doing that. So firstly, let's add a new reference up here to the processes library. So we'll go and add it up here, add reference, and I've added a reference to the processes library in my ramp installation folder. Okay, so now that I've done that, generate the local range. So I need to import, from ramp.processes, import local statistics. So let's have a look at that again in the documentation. This was the processes DLL that we added a reference to. This is the namespace, and we're importing the local statistics class, which includes all of these methods that are available to me. Now let's go ahead and create a variable called range raster, which will actually be a raster that comes from the local statistics range method. Now, if I remember the arguments, I needed to pass into it a raster, so I'm going to pass the original input raster in there, and a kernel size, which is 9. So that's now gone ahead and calculated the localized range using a 9x9 kernel and returned the range raster. Pretty easy. So now I need to save the resultant file, i.e. range raster, out to a new raster. So again, I'm going to go to my utilities, and I'll see that I have a method called write that allows me to pass into it a raster and define the path to an output file and a particular file format. So these file formats are interesting, and they're documented here. So refer to the readers and writers documentation for a listing of the standard format codes. And you can see previously we imported using ramp, but I can use any of these standard format codes to define what the output file format will be. So we're still going to stick with a ramp binary grid. Okay, so save the resultant file. So I'm going to call utils.write, and it needs the range raster is the one that I want to write, and it's asking for a file path. So I'm going to put it in, actually what I'm going to do is I'm going to use the original file, and I'm simply going to append to it .range.ramp at the end of that, .rmp at the end of that file, and I'm going to tell it that I want to export ramp file format. Okay, that's essentially my logic completed. What I probably will do now is just put some sort of, not decorations, but some comments in here that will go to the console. So what we'll do is we'll say here, print, and we will print that we are going to, actually we won't print, we'll use another utility. So if I go back to the documentation for utils, you'll see I can output a message. So I can call utils.out, pass a string and output a message. And this does all sorts of things in terms of formatting that message, but it's also used for exception handling and various other things. So I'm going to use that. So go back here and I'm going to say utils.out, and we'll say that we're about to, what we'll do is we'll put something, we'll say processing and we'll list the file name. So this will output that it's about to process that particular file name. And at the end we will say utils.out completed. And at the end of the for loop we'll say utils.out done all. Okay, I'm happy with this now. What we're going to do is we're going to go through and run this and see what it does to input data and what output data it generates. So let's quickly save that and then run it. And it's come back with an error to say, hang on, I don't know what utils is, because of course, silly me, I called utils before I had actually imported it. So let me just change that around and we will be good to go. So let's move that from here. And we will write that we're processing that file after we have actually imported the utils. This should be good to go. Fingers crossed. Second time a charm. Spelling mistake. Local statistics. Local statistics. Okay, let's go fix that bug. Statistics. Local statistics. Too many C's. Alright, let's run that. This has got to work now. And sure enough, it's run through and you can see where it has said processing, done a whole bunch of stuff, calculating the kernels, exported the file, processing the next file, etc, etc, etc. So this has been a quick example of how you can write a very simple Python script leveraging the RAMP API through the use of the Pythonnet common language runtime sort of bridge or wrapper. I hope this has been useful to you. I hope you can see how you can do some very powerful things by tacking together and integrating the RAMP API with some logic and control flow that you build using Python. So thanks for watching, and I hope this has been useful.